Hi guys, welcome again to the Unit 1, the Requirements Engineering. We continue with the third topic. This is about specification and validation of requirements, and we focus on the standard of the IEEE 830. And in the SRS templates, we show or we learn how we can apply or how we can use both of them. But we start with the requirements specification. The requirement specification is the process of writing down the user and system requirements in a requirements document. Ideally, the user and system requirements should be clear, unambiguous, easy to understand, complete, and consistent. In practice, this is almost impossible to achieve because sometimes stakeholders interpret the requirements in different ways, and there are often inherent conflicts and inconsistencies in the requirements. The user requirements are almost always written in natural language, supplemented by appropriate diagrams and tables in the requirements document. The system requirements may also be written in natural language, but order notations based on forms, graphical system models, or mathematical system models can also be used. The system requirements, we have a table in the slide about the notation and description about the natural language sentence, the structured natural language, and the graphical notations and mathematical specifications. The user requirements for a system should describe the functional and non-functional requirements so that they are understandable by systems user who don't have detailed technical knowledge. Ideally, they should specify only the external behavior of the system. The requirements document should not include details of the system architecture or design. Consequently, if you are writing user requirements, you should not use software or structure notations or formal notations. You should write user requirements in natural language with simple tables, forms, and intuitive diagrams. The system requirements, on the other hand, are expanded versions of the user requirements that software engineers use as the starting point for the system design. They add detail and explain how the system should provide the user requirements, and they may be used as part of the contract for the implementation of the system and should therefore be a complete and a detailed specification of the whole system. Ideally, the system requirements should only describe the external behavior of the system and its operational constraints. They shouldn't be concerned with how the system should be designed or implemented. However, at the level of detail required to completely specify a complex software system, it is neither possible nor desirable to execute all design information. And for the natural language sentence, the requirements are written using numbered sentence in natural language. Each sentence should express one requirement. For the structured natural language, the requirements are written in natural language on a standard form or template. Each field provides information about an aspect of the requirement The graphical notations are graphical models supplemented by text annotations and are used to define the functional requirements for the system. The UML, or Unified Modeling Language, use case and sequence diagrams are commonly used. The mathematical specifications, these notations are based on mathematical concepts such as finite state machine or sets. Although these unambiguous specifications can reduce the ambiguity in the requirements document, most customers don't understand a formal specification and they can check that it represents that they want, and they are reluctant to accept it as a system contract. Then exists a software requirement document. The software requirement document, sometimes called the software requirement specification or the SRS, is an official statement of what the system developers should implement. It may include both the user requirements for a system and a detailed specification of the system requirements. Sometimes the user and system requirements are integrated into a single description. In other cases, the user requirements are described in an introductory chapter in the system requirements specification. The requirements documents are essential when systems are outsourced for development, when different teams develop different parts of the system, and when a detailed analysis of the requirement is mandatory. In other circumstances, such as software product or business system development, a detailed requirements document may not be needed. Agile methods are that requirements change so rapidly that a requirements document is out of date as soon as it is written, so therefore it's largely waste. Rather than a formal document, Agile approach often collect user requirements incrementally and write these on cards or whiteboards as short user stories. The user then prioritizes these stories for implementation in the next increment of the system. For business systems where requirements are unstable, I think that this approach is a good one. However, I think that it is still useful to write a short supporting document that defines the business and the dependability requirements for the system. It is easy to forget the requirements that apply to the system as a whole when focusing on the functional requirements for the next system release. The requirements document has a diverse set of users, ranging from the senior management of the organization that is paying for the system to the engineers responsible for developing the software or the system. And we have in the slide the most of the users that interact with the software requirements document. In this case are system customers, manager, system engineers, system test engineers, and system maintenance engineers. All of them have different interactions with the software requirements document. The diversity of possible users means that the requirements document has to be compromised. It has to describe the requirements for customers, define the requirements in precise detail for developers and testers, as well as include information about future system evolution, information on anticipated change, help system designers to avoid restrictive design decisions, and maintains engineers to adapt the systems to new requirements. The level of detail that you should include in a requirements document depends on the type of system that is being developed and the development process used. Critical systems need detailed requirements because safety and security have to be analyzed in detail to find possible requirements errors. When the system is to be developed by a separate company, the system specification needs to be detailed and precise. If an in-house iterative development process is used, the requirements document can be less detailed. Details can be added to the requirements and ambiguities resolved during the development of the system. And we have a table that shows one possible organization for a requirements document that is based on an IEEE standard for requirements document. This standard is a generic one that can be adapted to a specific use. In this case, the standard has been extended to include information about predict system evolution. This information helps to maintainers of the system and allows designers to include support for future system features. And we have some chapters and their descriptions. We have a preface, introduction, glossary, user requirements definition, system architecture, system requirements specification, and system models, system evolution, appendices, and the index. Naturally, the information included in a requirements document depends on the type of software being developed and the approach to development that is to be used. A requirements document with a structure like that shown in the table, for example, might be produced for a complex engineering system that includes hardware and software development by different companies. The requirements document is likely to be long and detailed. It is therefore important that a comprehensive table of contents and document index be included so that readers can easily find the information they need. By contrast, the requirements document for an in-house software product will leave out many of the detailed chapters suggested in the table. The focus will be on defining the user requirements and high-level non-functional system requirements. The system designers and programmers use their judgment to decide how to meet the outlined user requirements for the system. And the next step is the requirement validation. The requirement validation is the process of checking that requirements define the system that the customer really wants. It overlaps with elicitation and analysis as it's concerned with finding problems with the requirements. Requirements validation is critically important because errors in a requirements document can lead to extensive rework cost when these problems are discovered during the development or after the system is in service. And the cost of fixing a requirements problem by making a system change is usually much greater than repairing design or coding errors. A change to the requirements usually means that the system design and implementation must also be changed. The system must be retested in that cases. During the requirements validation process, different types of checks shall be carried out on the requirements in the requirements document. These checks include the validity checks, and this check that the requirement reflects the real needs of system users because of changing circumstances. The user requirements may have changed since they were originally elicited. And the question in the check to answer is, does the system provide the function which best support the customer needs? And for the second, the consistency checks, requirements in the document shouldn't conflict. That is, there shouldn't be contradictory constraints or different description of the same system function. We have a question to answer in this check, that is, are there any requirements conflicts? It's important in this point. The completeness check, the requirements document should include requirements that define all functions and the constraints intended by the system user. The important question here is, are all functions required by the customer included? And we have a relevance check. By using knowledge of existing technologies, the requirements should be checked to ensure that they can be implemented within the proposed budget for the system. These checks should also take account of the budget and its schedule for the system development. The question here is can the requirements be implemented given available budget and technology? The verifiability to reduce the potential for dispute between customer and contractor, system requirements should always be written so that they are verifiable. This means that you should be able to write a set of tests that can demonstrate that the delivered system meets each specified requirements. And the important question here is, can the requirements be checked? And we have an image in the slide explaining how the customer think a solution, or how they explain the needs that they have, or the problem, and finally the process about all the people involved in the development of this solution, and finally what the team or the company implements. And of course it's very different from the thing that the customer thought. And that explanation in image, it's very important to understand that sometimes when the process of the requirements gathering, the analysis in this part of the process, and the requirements validation, of course, all of these parts are very important to make or to cover with the expectations that the customer has, because if not, we can construct something different that they are expecting. And We have a number of requirements validation techniques that can be used individually or in conjunction with one another. The first one is the requirements reviews. The requirements are analyzed systematically by a team of reviewers who check for errors and inconsistencies. Regular reviews should be held while the requirements definition is being formulated. What to look for in this point is that you need to cover that it's the verifiability. Is the requirement realistically testable? The comprehensibility. Is the requirement properly understood? The traceability. Is the origin of the requirement clearly stated? The adaptability. Can the requirement be changed without a large impact on other requirements? And we have another techniques, it's prototyping. This involves developing an executable model of a system and using this with the end user and customers to see if it meets their needs and expectations, and the stakeholder experiment with the system and feedback requirements change to the development team. Or we can use the last one, that is the test case generation. The requirements should be testable if the tests for the requirements are devised as part of the validation process. This often reveals requirements problems. If a test is difficult or impossible to design, this usually means that the requirements will be difficult to implement and should be reconsidered. Developing tests from the user requirements before any code is written is an integral part of test-driven development. You shouldn't underestimate the problems involved in requirements validation. Ultimately, it is difficult to show that a set of requirements does in fact meet user needs. Users need to picture the system in operation and imagine how that system will fit into their work. And it is hard even for a skilled computer professional to perform this type of abstract analysis, and harder still for system users too. As a result, you rarely find all requirements problems during the requirement validation process. Inevitable further requirements change will be needed to correct omissions and misunderstanding after agreements has been reached on the requirements document. Then we have general requirements engineering process. The requirements engineering involves three key activities. These are discovering requirements by interacting with stakeholders, sometimes or we know as elicitation and analysis. The covering these requirements into a standard form or the specification of the requirements. And we have the tier one, and checking that the requirements actually define the system that the customer wants, that it's the requirements validation. We have a figure or a picture that shows this sequential process and how these three activities interact. However, in practice, requirements engineering is an iterative process in which the activities are interleaved. The activities are organized as an iterative process around a spiral. The output of the requirements engineering process is a system requirements document. The amount of time and effort devoted to each activity in an iteration depends on the stage of the overall process, the type of system being developed, and the budget that is available. We have the picture of how the spiral function. Early in the process, most effort will be spent on understanding high-level business and non-functional requirements and the user requirements for the system. Later in the process, in the outer rings of the spiral, more effort will be devoted to eliciting and understanding the non-functional requirements and more detailed system requirements. This spiral model accommodates approach to development where the requirements are developed to different levels of detail. The number of iterations around the spiral can vary so that the spiral can be excited after or all of the user requirements have been elicited. Agile development can be used instead of prototyping so that the requirements and the system implementation are developed together. In virtually all systems, requirement change, the people involved develop a better understanding of what they want the software to do. The organization build the system change and modifications are made to the system hardware, software and organizational environment. Change have to be made to understand the impact on other requirements and the cost and system implications to making the change. Of course, at the beginning of the project, the part of the requirements has a lot of variability, but when the steps or the process are followed and the requirements are very clear, and of course we reduce this variability about what the customer want and what the development team understand about these requirements. And we have some body of knowledge. Have three important structure taxonomies or body of knowledge exist for requirements engineering of software systems. We have the software engineering body of knowledge and the graduate software engineering referencing curriculum and the principles and practices of software engineering exam specification. These bodies of knowledge focus on the discipline of software engineering, but they can be applied to the engineering of any kind of system. And doesn't matter if it's software, electrical, mechanical, or hybrid. And there are also emerging referencing body of knowledge related to system engineering. For example, the guide to the system engineering body of knowledge, the graduate reference curriculum of system engineering, and the Association for Computing Machinery, and the Institute for Electrical and Electronics Engineers, the Computer Society curriculum guidelines for undergraduate degree programs in software engineering. And there are also focus significantly on requirements engineering process and activities. And we have an image that describes the the standards and body of knowledge that exist in actually, and you can use one of them, but we are focusing on the standard of the IEEE 830. And that's it, guys. Hope you you understand all of that information about requirements. And it's important that you can use a lot of options, or you can have a lot of options to use in the requirements engineering, or the process of the evaluating all the requirements for one software project or for other kind of projects. You can use all of that body of language of knowledge, and of course we apply, or we mix some of them to get a better understanding of the requirements of our customers. Then that's it, and thank you so much for listening me. And remember, proudly